Good morning, good afternoon, or good evening, depending on where you are in the world today. And welcome to today's learning experience brought to you by JFrog. My name is Jared, and I'll be your host for today's Techstrong learning session. We've got an exciting panel ahead of us, but before we begin, we do have a few housekeeping notes. Today's event is being recorded, so if you miss any of our discussion or you'd like to share with a friend, the on-demand recording will be made available to you shortly after the webinar concludes, with a link for you to access as well. If you have any questions, we'd like you to submit them in the Q&A tab on the right side of your screen. This is also where you'll find the chat tab, where you can engage with with our speaker and fellow audience members, share your thoughts, or just tell us where you're signing in from. We're also giving away 4 Amazon gift cards at the end of the session to the best questions that come in. So please be sure to ask questions and stick around through the entire program. Let's go ahead and kick off today's topic, a guide to smart dependency management. Today we're joined with Batel Zohab, developer advocate at JFrog. Batel, thank you for being with us. Do you want to go ahead and take it away from here while I turn off my camera?
Yeah, of course. Thank you very much, Jared. So first of all, it's a pleasure to be here. Thanks everybody for joining today. It's so cool to see some people from Portugal. So tell me more. Tell me where are you from? I would love to see some people all over the world, and I hope you enjoy the session today. So thank you very, very much for joining. So today we're going to talk a bit about a guide to a smart dependency resolution, right? What do you think it is? Share with me your thoughts and what do you think it could be? So in the meantime, I'll just present a little bit about myself. My name is Batel Zor, and I'm a developer advocate in JFrog. I'm working in JFrog in the last 7 years, almost 7 years. I've been part of the support team, then moved to the high-touch solution. Before JFrog, I was an embedded developer, so I worked with C, C++, and other technologies. I have 2 amazing doggies named Banjo and Sol. She is more crazy, but if you're a doggies person, share with me some picture too. It could be cool. And you can find me on LinkedIn, Twitter. Feel free to ask me anything. So here's my email if you have any question later on, or just want to share with me some cool stuff. I would love to hear more about DevOps, DevSecOps, and see what is your current solution. And really, do not hesitate to just reach out to me. I would always happy to help. And if you need something, I'm here. So I think we can see. All right, cool. So let's check the chat. Wow, we have here some Jared from USA, of course. Germany, Bosnia, India, and Nigeria. Wow, that's so cool. So all over the world. So I think we can kick it off and let's start. So Word runs on software, almost 7% is open source, right? So some of you may agree with me, some of you may disagree, but I guess that all of us using some open source, some dependency, none of us would really love to invent the wheel from scratch, right? Usually I prefer to take something that someone already created and just change it a bit, add it to my software according to my need, of course. But I probably won't invent something new or just create something based on something. So a lot of people using open source. And today's presentation is about a key part of our software development processes. Dependency, right? We don't need to reinvent the wheel, as I said before. Every time we want to achieve some new level of functionality or deliver software faster or just adding something, we want to do a reuse software written by others every day, right? Like software dependencies. I can easily take this class, this dependency, this a lot of different ways, and we're going to talk a bit about it today. And this process sometimes not examined closely, right? So we need to think what we're doing with this dependency. Maybe it could be dangerous. Maybe it's great. Let's talk a bit about dependencies and see what do you think about it. So dependencies in the software development, we need them for testing, for runtime, for development, and they are integral part of the software development lifecycle, and they will be used in different stages of the development. It could be everywhere, as I said before, in the development part, in the runtime, in the test. And I guess that some of you heard about the definition of quality gates and why it's so important to create different quality gates. So I'll try to touch it a bit later on. But the idea here is also to find what is the right dependency and when we should use it. So dependencies, not all of them are the same, right? Some of them may be a bit different. Some of them may contain some security vulnerabilities. Some of them are good, but some of them are just not allowed in our organization, right? With some licenses issues or something like that. So let's talk a bit about that and why they are so different. So today I'm going to share with you two statements and you are going to tell me if it's true or false. I would love to see your answers in the chat. So let's start. Dependencies are a collection containing high quality tested code that provides functionality that requires significant expertise to develop. So what do you think about it? Is it true? Is it false? Let's see what do you think on the chat. Let's wait a second. True. All right, cool. False. Who else? Ooh, nice. We have some false here. All right. And what do you think about dependency managers like NPM have made possible that almost trivial functionality can be packaged and published? What do you think about this statement? Is it true? Is it false? Like if I'm going to use NPM, for example, I am safe as a developer. I can just use whatever we have there. All right, true. Cool. All right. So yeah, both are sides of the spectrum, right? Like it's totally different two sides, and there are different type of dependencies, of course. It's not just a dependency. So let's try to deep dive a bit about that and talk about framework, libraries, packages, modules, and resources. Most of you probably heard about it, right? About all of these definitions, and there are a lot. They are part of our development. Sometimes we're going to use a framework. Sometimes we're going to use a library, and sometimes packages. All right, true but incomplete. I love this answer. Thank you. So resources might be a collection of files, right? For example, templates, media like audio, video, images, plain text, or blobs that needs to be included by the application to execute correctly. Sounds reasonable, right? Like resources could be a collection of files. I think I can agree with that. So we had media, plain text, we have blobs, we have a lot of information here. But when we're talking about a module, right, maybe it could be a bit simple set of methods and functions that provide a self-contained functionality. A module usually has an interface that specifies both functionality and it provides as well all the functionality depends on. All right, kind of, right? Let's talk a bit about a user perspective. It's kind of a black box in that case, right? Like we don't really know what exactly do we have in this module. We just want to take this module and use it. So in that case, we have a set and we have an interface. Okay, sounds reasonable. So we have specify both the functionality it provides and as well the functionality it depends on. And this interface has at least one implementation, which from the perspective of user is black box again, right? Because we are not exactly know what it's going to show there. Then we have the package. So if we talked about NPM before, we have a collection of modules that hold in general the same functionality purpose, usually a directory that contains a file that describes metadata about the package. And this aggregation of functionality makes it easier. And basically, it's include all the related modules at once, right? So we have a collection of modules that hold in general the same functional purpose, usually a directory that contains a file that describes metadata about the package. So I guess that you're all using different packages. If you would like to share it on the chat, it could be cool. And you can imagine how it's going to look like, right? So we have, for example, a jar that contains a few files, the npm file, the npm rar, and so on, the zip. So it could be different from one to another. And the last one will be a library. Library is a collection of related functionality defined in several packages. It's essentially a set of functions that you can call. Each call does some work and returns control to the client or application that's executed by function. All right, sounds pretty simple, right? Like whenever you just started your development, you probably added some library, like IO libraries and so on. So you saw how I'm going to get the function, how I'm going to use the IO and input, output, and so on. And it's pretty simple, let's call it, right? So we have a collection, we have packages, we have returns control. We would like to make sure that we can support it, and we have everything we need here. All right, so this is pretty simple, kind of. And the last one, it will be a framework. So a framework embodies some abstract design with more behavior building. In order to use it, you need to insert your behavior into various places in the framework. The framework code then calls your code at this point. Again, simple. Let's find it. We have the behavior, we have the insert. We need to make sure that we have everything we need here. All right, so it's more behavior building. And in order to use it, we need to insert our behavior, as we said before. And the framework code can then calls to our code at these points. Cool. Pretty simple, kind of, but let's make it a bit more interesting. So as an example, let's talk a bit about Angular. I guess that most of you are already familiar with Angular. Let me know if not in the chat. But Angular is a platform, right? And React is a library. If we will try to talk about the difference between them, we have our framework platform and we have our library, and the JavaScript library for building user interface, which is Angular, and then a modern web developer platform. All right, so on the smallest side of NPM packages, we have a collection of micro NPM packages, right? We have very, very small micro NPM packages. All right, so this is very, very small and created before 4 years, and just as an example. And we have discussed about the different type of dependencies that we can have in our application, and having clear idea of the difference help us to define it. So dependencies are crucial, right? I guess that we are all agree here that dependencies are crucial and important and easily exchanged, right? The idea here that I can just easily change the dependency that I'm using today to something newer that contains some other features, or something that is newer and contains some security fixes. And we need to think about the need of dependency level. It's also very important. So this information helps us to decide a cadence of update, migration costs, or cleanup effort needed during the development process. So we have normal consideration even when dependencies are okay and everything is as should be, right? So I just took whatever I need. I have my dependency, my code is up and running, and it's working on my machine, right? Everything is working well for me. So why I need to take caution at all, right? What can possibly go wrong? Everything is perfect. I can show my team lead, I can show my friends that I created exactly what they asked me to do, and the code is running, and what could goes wrong, right? In that case, so actually adding a dependency outsource the work of developing that code, designing, writing, testing, debugging, and even maintaining to someone else could be pretty hard, right? We always said that it works perfectly on my machine, but using a code actually expose the program to all the failures and flaws in the dependency. Think about it, that it's not only developing by one single developer, right? In most of the cases, you have a team that's working together, and you have a team that's creating one huge feature or a few features or just a version, and it's not only on your machine. Today, it's much more than one machine. All right, so closed code and open source, right? Let's talk a bit about open source. Decades ago, most developers trusted others to write the software they depends on. So let's talk a bit about OS system, like operation system, and the compilers. The software was purchased from a known resource, often with some kind of support agreement, and there was still a potential for bugs or outrage machine, but at least the developers knew who they were dealing with and usually had a commercial or legal resources available, right? Think about yourself before a few years. You probably had whatever you need. You got your OS system. It doesn't really matter if it will be Linux or Windows, and You trust that it will work. You trust that won't be any security vulnerabilities and everything goes well. And open source software has changed how we approach the software. When reuse was difficult, there were fewer projects publishing reusable code packages, and the commercial and legal support for trusting software sources was replaced by reputational of support or popularity. So I can give some example about myself. Like before a few years when I was a developer, it was very easy to, I think more easy even from today, to get the support of the community, right? Like if you have any bug or something that you actually request as a feature on an open source library that you're using, I think it was much more easier to talk to the maintainers, to support it together. I think here, of course, there are still some projects that are running today that are great, that you can always share and support and get the information. But for my opinion, I think it was easier. Like I can just open something in the GitHub of this project and get the information. It was pretty simple, kind of. Now, let's go back to NPM for a second and why it's so critical. So, in March 2016, a package called LeftPad, which many popular JavaScript packages depend on, was unpublished as a result of the naming dispute. And although the package was republished 3 hours later, it caused widespread disruption, leading NPM to change its policies regarding unpublishing. Think how much it was crazy. So, since it that usually we're not unpublishing or removing version. It's not the best practices, so it just got unpublished since it makes so mess all over the place. Now, the second example is February 2018. And there was an issue that discovered in version 5.7.0. Maybe some of you remember it, maybe some of you are not. And it's running sudo npm on Linux system and would change the ownership of the system files. So think about it. I'm just running sudo npm and then I'm changing the system files. I don't think we want to provide this permission, right? We want to make sure that we are secure. We all know how much security is important and why we won't like to run a sudo every time. So it's breaking the operation system, right? Which was pretty big issue. Now, then let's go back to 2018. Look how many issues just in 2018. So July 2018, we have the NPM credential of a maintainer EastLint scope packages and were comprised, resulting in a malicious release of this specific EastLint scope version was 3.7.2. The malicious code copied to the NPM credential of the machine running the specific package, which called EastLint scope, and then just uploaded them. So it's copied the NPM, got the credentials, make a huge mess all over. And in November 2018, it was discovered that malicious packet had been added as a dependency to version 3.3.6 of event stream. If you heard about this package, the malicious package called FlexMap stream and contained an encrypted payload that stole Bitcoin from certain application. So, and of course, we have much more, right? We can deep dive to much more than that, but this is kind of big shot that I try to collect. So we have April 2020 and it Parmes, which is a small package actually, and result in outage serverless application. So again, even the small packages could be a big mess sometime. In January 2022, the maintainer of Colors, I guess it's more actually pretty much more interesting and more renewal. So, and the maintainer of Colors pushed changes printing garbage text in an infinite loop. The maintainer also cleared the repository of another popular package called Faker and its package on NPM and replaced it with a README that read what really happened to Aaron Schwartz. All right, and I have some other example, for example, in NPM that was related to some related to politics stuff, and I'll share with you some more packages if you are interested later on. But as you can see, it's all over, right? It could be from the smallest packages to very, very large packages and really change the world. Now, all right, it's cool. We have a research team actually in JFrog that's adding more tools and information about different packages. So I try to focus a little bit more about NPM. So we have the malware, civilware, and malicious NPM packages targeting malware authors. So we saw this place. And we also created some open source tools that help you to defending against malicious NPM packages. So that's nice, and we can always use it. But I think it's not always enough, right? We need to make sure that we are always secure our dependencies. There is a lot of tools all over the world. And what about SCA, right? Some of you may heard about SCA, which is software composition analysis. And we need to make sure that we attached our Artifactory and fully automated binary analysis capabilities. So I hope all of you already heard about the JFrog platform, and if not, I'm going to show it in a few slides from now. And we want to make sure that we are detecting our previously unknown supports all major packages type and seeing to all layers and dependencies of packages. So for example, so far I try to focus on NPM, but what we're going to do if we're using Docker, right? We have a lot of layers of the Docker. We want to make sure that the OS system of the Docker is secure. And inside of it, if I have a package, for example, a Java package or something like that, I want to make sure that I'm going to scan it too. So what I'm going to do in that case, I want to make sure that I'm secure from when I just started to build my code to my distribution. Now, of course, there is a great open source tool that I really recommend you to try too. So if you didn't heard about OSAP, it's the Open Web Application Security Project. It's a non-profit foundation that works to improve the security of the software, which is really cool. They have great projects. So feel free just to search for OSAP. So we have a guide evaluating source software. So it's really nice with some best practices, what it's important to have here. We have scorecards. If you heard about it, it is an automated tool that assess a number of important heuristic kind of checks that associated with the software security and assign check of score from 0 to 10. So you can easily just use these scores to understand specific areas to improve in order to strengthen the security of your project, right? We all heard about, here is our Log4j. I waited for it so long. Thank you so much, Pedro. So actually, it's a great. Let's talk about Log4j for a second, right? I guess that most of you heard about Log4j or suffered from Log4j. So actually, a really interesting question about it is how long it took you to solve Log4j, right? I love to ask it. So Pedro, can you please let me know how long it took you to solve Log4j? And other people, of course, I would love to hear more about your issue, kind of, and if you suffered from here. Oh yeah, it was a nightmare. I agree. That was Friday, if I remember correctly, right? It was pretty annoying. So you can also access the risk that dependencies introduce and make informed decision about accepting this risk or evaluate the alternative solution or working with maintainer to make an improvement. So this is specifically for the scorecard, but you're amazing. Thank you very much. And other people, can you please let me know how long it took you to solve Log4j? Have you suffered from Log4j? Oh, wow. Still patching system? Wow. That's impressive. So I'm going to show you later on how you can manage it maybe a little bit faster. So we have one afternoon. Yeah. All right, so we have a guide for developing more secure software, as I said before. I think it's very easy to understand and work with it. Now, let's talk a bit about surviving software dependencies, right? It's created by Russ Cox, and we would like to close code to open source code. So, as I said before, decades ago, most developers trust others to write the software they depend on, right? I don't think it was so popular or so cool to talk about security, right? A lot of people was aware, kind of, but sometimes the developer just didn't care too much about it, right? Like I remember myself, I need this specific dependency. I don't think there was enough awareness for security those days. Like everybody just needs something. We got the dependencies. We make our software work as expected, and everybody was happy. So that software was purchased from known source, often with some kind of support, as I said before, and there was still a potential for bugs, of course, because any software development won't really be able to make sure that everything's working correctly, right? And sometimes you request to get an update, and actually my actually, if we're talking about it, my from my experience, it was sometimes really hard and very long updates, right? Like try to remember yourself when we were updating your OS system. I never forget it. I was like 14, maybe 15 years old, and it took around 3-4 hours, maybe a little bit more, just to update the OS system. Right? Think about today, about the updates that you have all over. If it's in your phone, if it's in your computer, you don't even notice sometimes that you're updating your software. Right? In some cases, my iPhone will just update automatically. I don't care about it. Everything will work, and I don't even notice that there is a new update. Sometimes the changes are so small that nobody knows. But today things change, right? We care much more about security. We heard more about DevSecOps and why it's important. And the cost of adopting a bad dependency can be viewed as the sum over all possible bad outcomes of the cost of each bad outcome, multiplied by this probably of happening risk, right? Because there is a lot of risk when we're using a dependency that contains security vulnerability, as we said, like log4j and other dependencies, and sometimes it could be very, very costly, especially something that can harm our OS system or some servers and so on, or get into our system. So as it's more unsecure or more explosive, it could be, of course, much costly. So let's try to inspect the dependency. Is the documentation clear? Does the API have a clear design? So let's talk a bit about a dependency, right? When we're just trying to get a new dependency, usually we'll search for the functionality. Ask someone in a team, maybe he knows this specific dependency and so on. Start to read about it. Let's think what could happen when we're using this dependency. So as I started, we have the documentation. Is it clear? We have a clear design, or it's a bit too messy, right? Maybe I need this one, and then maybe it will be too complicated. Maybe someone can find a bridge inside of this specific API. Another thing that we need to talk about is actually, of course, the code quality. Is the code is well written? Is it let's try to read some of it. Does it look like the others have been careful, right? If they have any conscience or consistent, or just some different maintainers, and maybe it's a bit messy again. Does it look like a code that you would like to do? You would like to debug? Because after all, I'm using it. Maybe I need to change it a bit, and maybe it's too many loops over there, right? Maybe it's too many functionality that's calling something else. Maybe just too much, and I can't really debug it. And then I need to think twice if I really want to use this specific code. Now, testing, of course, it's super important. So does the code have the tests? Can you run them? Do they pass all the tests? Tests establish that the code basic functionality is correct, and they signal that the developer is serious about keeping it correct. So again, whenever I'm looking for something new, or if even you will open our repository, you will see the test. You can see what run there, if something goes wrong, why it goes wrong. I want to get this information as a developer, right? I want to make sure that I'm trusting something that tests as well, that go through everything we need and everything we want to make sure that it's part of our. Let's take our small list of things that we need to make sure when we're using this dependency. Bug fixes, right? We need to make sure that the package have an issue tracker. Are there many open bug reports? How long have they been open? Are there many fixed bugs? Have any bugs been fixed recently, actually? Right? Maybe someone just reported a bug a year or 2 years ago and nothing changed, right? I guess that I may want to use something with maintainers, something that people support and change it. Maybe it's okay, just to use something all that remain the same. Because after all, we can't really replace everything. Think about the simple calculation on Linux, right? It didn't change, I think, for 10, 15 years. I'll double check myself, but nothing changed because the math rules didn't change too, right? They remain exactly the same. Nobody really changed the plus, the minus, or whatever. It remained the same, so maybe we don't really need to fix them. And maintenance, right? Look at the package commit history. How long has the code been actively maintained? Is it actively maintained now, or packages that have been actively maintained for an extended amount of time are more likely to continue to be maintained? And how many people work on the package? Like many packages are a personal project the developer create and share to fun in their spare time. A lot of people that will trying to get their first job or just love to code and they are sharing the code all over. And it's cool, but others are the result of thousands of hours of work by a group of paid developers, right? There is also the paid campaigns that you can see and some open source version that a lot of companies evolve. And in general, the later kind of package is more likely to have promote bug fixes and improvements and general upkeep. And we want to make sure that everything is up and running. And usage is also pretty important. So, do many other packages depend on this code? Dependency Manager can often provide statistics about usage, or you can use a web search to estimate how often others write about using the package. So, we want to make sure that a lot of people also using this package, and then we can get some more tracking and more information about it if there is a bug, if there is security issues. And more users should at least mean more people for whom to code work with well enough. Along with faster detection of new bugs, widespread usage is also hedged against the question of continued maintenance. And if a widely used package loses maintainer or intercept a user, it's likely to step forward. So think about also about the usage, about the maintainers, and about the people that we have there. Are we able to trust it? Right? Is it secure enough? And of course, security, right? Will you be processing untrusted, input with the package? If so, does it mean that they're robust against malicious input? Does it have a history of security problem listed to the NVD? We need to check so many things when we're using dependency that sometimes we are just using it, right? And we don't care enough about it. And I think it really need to be something that our developer need to take on and take it seriously, actually. And of course, licensing, right? Everybody heard about licensing. It's not like just adding the license to your software. It's actually open source licensing. So is the code properly licensed? Does it have a license at all? Or is the license acceptable to your project or your company? A surprising fraction of projects on GitHub have no clear licenses. So let's talk a bit about licensing for a second. So I'm not sure how many you know about licensing, so I'll try to make it clear and quick. We are talking about open source licensing like Apache, for example, and we want to make sure that our organization support it. So if you can, I'll just serve with some link later, but there is so many companies that have some issues when the developers used an open source licenses and then they was getting some law and suits and they need to share their code sometimes even. Think about the idea that you was really innocent, right? I just used this dependency and then a week or a few days or month later, I need to expose some of my code because I used an open source license that enforced me to share this specific function, to share this code or stuff like that. It could be pretty dangerous actually. And dependencies. So does the code have dependencies of its own? Maybe there is an indirect dependencies that are just as bad for your program as flows indirect dependencies. So dependency manager can list all the transitive dependencies of a given package, and each of them should ideally be inspected as described in this section. So we want to make sure that we have everything. We have licensing, we have security, usage, maintenance, bug fixing. We want to find all of this information very, very quickly. So we have the dependency level quality, right? What is more important? What we need to search right now, where we need to take it to the licensing part, to the security maybe, to the dependency, to the maintainer. What will be our coordinates in that case? So of course it will be much easier if we will have one tool that do that all, right? It centralize everything. And for that, actually, we have our DevSecOps platform, which is starting from here, from the development to the distribution. And let's talk a little bit about each and every one of them. So first, we have Artifactory over here. So I hope all of you already heard about Artifactory, but if not, Artifactory is a binary repository manager that supports more than 28 different package types like Docker, NPM, Rust, even Terraform, and other packages that help me to contain and store and manage all of the binaries that I have in one place. And it's basically separated to three different package types. We have our three different repository types, three different repository stories, the local, remote, and a virtual one. So inside my local, I'll add everything that I just created. Inside my remote, I will get the information from other repositories. So for example, in NPM packages, we will take our dependencies from npm.js. Then we can aggregate it with virtual one that contain few different repositories in one place. So imagine kind of an envelope for the NPM and kind of an envelope for the Docker that contain different locations to get the binaries that I need to develop my code. Then I have my X-ray to make sure that I'm clear and secure from compliance issues. So whenever I'm having the whole platform, I can easily secure my binaries. As we talked about Log4j before, I can easily find all the packages, all the versions, or everything that contain Log4j. I can just search for it and get all of the information. And of course, I can block it. I can create a policy. I can automate stuff. So in case that I'm finding something which is critical, I will let the developer, I will let the team leader, I will update whoever needed with this information. We have distribution and connect. They are kind of together, but not exactly. The idea here is to distribute our release, everything that is ready to release to different location. I can easily distribute it to another servers. I can even deploy and operate and monitor software in the IoT devices. And I have our CI/CD, which we call pipelines, and mission control and insight to monitor and tool and monitor and analyze everything that we have in this platform. So basically, I'm kind of covered in that case, right? I have everything I need from one place to another. From my VCS code, I also have here some integrations and some extension that I can easily add and see everything when the developer is just starting to create his code. So for example, I can write my dependency and get some information directly from X-Ray inside my VS code that's telling me your dependency contains security vulnerabilities with this level. Are you sure you want to use it? Maybe you would like to use another dependency and so on. And basically, this is Artifactory and X-Ray. This is the basic one. You're going to get the link, I guess, later on that will show you how it's working, what we're doing here, and with a step-by-step. And if you didn't heard about Frogbot, it's also really, really cool. So Frogbot is our tool, our Git scanner. You can find it. It's an open source tool that scans the pull request for security vulnerabilities and open pull requests with fixes for security vulnerabilities. So I really love that we can easily filter it. Like we have, of course, no issues. Everything is green. That's the thing that everybody wants, right? Everything will be green and everybody will be happy. And if we found any vulnerabilities, we can easily filter them by severity, by a specific package, the version, and I get the information how to use it and what is going on here. So I really hope you would like to use Frogbot and try it, because it's free, it's easy. You can just add it to the Git very easily. And we also have other tools like Docker Desktop, that if you're running you see here the extension, the JFrog extension, it will let me know if there is any security vulnerabilities or not, which is super, super important. And here's the plugin that I talked a bit about before. So this is the IntelliJ version. So as I said, here's Log4j, Pedro, just for you. So if I'm looking for Log4j, I can see the impacted component. If there is a very fixed version, of course, I will get a fixed version over here. I can see the issue severity, the licenses, and the versions we're using very easily, so I can easily explore it. And what else we have? We have the JFrog NPM tools, like I showed with you the before. So we have a collection of tools to help to audit our NPM dependencies for suspicion packages and monitor dependencies for future events. So we have the NPM secure install, the package checker, and issue statistics. So you are more than welcome to go to our GitHub and find out those tools. And I think it's a great time for questions. And let's see, what do you have in the Q&A or in the chat? Thank you very, very much for joining today. I love to be here. All right, so I'll try to go to the Q&A tab. All right, how all this relates to internal dependencies or not public packages and repos. So by internal dependencies, you mean like another packages that we're using as part of our development, right? But you're like, I work with different environments, and in some cases we're using also internal and external dependencies that was written before and created before, right? Like in your internal dependencies, there is no code that we took from other dependencies from the internet or stuff like that. Like there is no chance that you're using also external dependencies as part of something all that you used and so on. So again, it depends, because maybe also in there we'll have some security issues. If the dependency, for example, let's take a Docker one that's running an OS system which contains some security vulnerabilities, is it still internal dependency in your end? I'm looking for an answer better. Thank you. All right. Anyone else? Any questions? How about tracking dependency to external API, like SaaS? All right. So you mean like if I have external APIs, you want to block them, you want to track it that they don't send the information, right? You want to make sure that we're not sending, let's say, for example, internal information and security code. So just a second, I'm going to show you how it's going to look like. Just give me 1 sec, and you're going to see it. I'm going to log into my JFrog platform environment, so you're going to see how it will really look. So just give me a moment, and I hope you all can see my screen. So Inga, I hope you can see that. So let's take, for example, one of my Docker images that I have over here. So first of all, of course, we have all of the information about the layers, the README builds, and all of other things. But I want to talk a bit about the X-ray data. So when we're talking about the violations and security, it's nice to have the security information, but it's not only that, right? Like how many times you install and use security tool, got thousands of security issues, started to investigate the most critical issue, but actually it's not really applicable on your machine, right? So I actually want to share with you Docker 78, just a second. Yeah. So 2 things. First, I want to show with you this report. It actually shows that 78% of the reported common CVs on the top Docker Hub images are not really explosible, right? It's not really a security issue, so I'll share it with you on the chat so you'll all have it. And let's focusing again on your question. So I got the information, I got the security vulnerabilities, but I also have services issues, application issues, and secret detects. So in case that we have any secret that is over there or any malicious packages that's sending something via the API, I'm going to see that over here. So I have all
Well,
the information. Yes.
we
Hi.
are still seeing the raccoon.
Oh, I'm sorry. So I'll share my screen again. Just a second. I'll just sharing on. Switch screen. I'm super sorry. All right, let's try to share it by window again. All right. Now, can you see me? Okay, cool. And if I'm moving here, you can see that. All right, so I'll just repeat. I'm sorry. So it turns out that 78% of the reported common CV on the top Docker Hub images are not really explosible. And if we're talking about APIs in that case and some external information that we are sending, we can also find it with the X-ray security tool and security issues, as you can see here. So first thing that I really like, it's the applicable and not applicable. So in case that we have something that is really applicable in our environment, I don't really need to just spend time and go and deep dive to something that is not really applicable. And here I can see the secret detection, services issues, and applications issues. So if it's something that's related to my API, I'm probably going to catch it over here and get the information. Rooney, can you create a scorecard? Right now you want me to create it? I can create it, but I'll send you the link. I think it will be easier than create it right over. I don't think we have too much time. But again, I send you my email. Feel free to start play with it. And if you have any questions, I would love to help with that. So just a second, I'll show you the link. Here is it. I hope you got it. I also share it on the chat. What else we have here? Answer. Okay, and security compliance licensing, etc. Ingo, you mean, again, just want to make sure that it's clear to me, you mean for the internal packages, or what do you mean by saying security compliance licensing and so on? What would you like to achieve here? Sorry, I didn't got it correctly. All right, let's wait another minute. This was related to the previous questions. All right, so we are talking about dependencies and external APIs or anything that I can catch, right? In case that I found any security vulnerabilities or anything that I can get as part of the information, I guess. Correct me if I'm wrong. So here's, for example, another RPM package, right? So I can see, let's see, something that contains some information here. Let's take accept, I hope. Let's take this one. All right, so you see, I see all the versions that I have here. I get the information over here. Let's go back. I'll go back to my Docker image, custom one here. And you can see that I have, first of all, the SBOM, right? Some of you heard about SBOM and CycloneDX and why it's important to get all of the information, first of all, as something that we can easily export and import to different location. So I can see in this specific Docker images, the common licenses. Of course, I can get the full list of all of them, components, which is most vulnerabilities. I can, of course, export the SBOM in different ways and get the information that I need over here. And if we're going back to log4j, for example, I can easily search for this specific log4j all over my platform. So as we said before, let's go by the products very easily. So we have the artifacts by the repositories that we have here. With all of the repositories that we created, we can create a different repositories for different packages. So as you can see here, we have Docker, we have Power, we have Maven, Swift, even Hugging Faces for all the machine learnings and AI people that we have all over. I think it's really, really cool, and you need to try Hugging Faces. We have Gradle, Go, and other packages that support it. And I get all of the information about it. So let's take, for example, an NPM one. Let's filter it very quickly. Let's take npm. All right, you can see the information about the package JSON. I can see the properties that we have here. I have followers if I want that another people will go and follow these specific changes that we have here. I have X-ray that provide me all the reports, and as we saw before, inside packages, I'll get the information together. So I can go to each and every package. Let's search for log4j. I hope we have something here. And yes, as you can see, a lot of log4j all over. So let's take one of them. I think this specific, it's not scanned, but here, our log4j. We have downloads, critical, different versions. They have the information and the location. So if we talked about how long it took you to solve log4j, think about a tool that I can easily search for log4j with the specific vulnerable version, and I can see all the repositories that contain it. So in one click, I can see that on the tree. I can go, I can block it, I can do whatever I want here that relates to my blocking or changing mechanism for this specific dependency. So I think it's very, very useful, right? It's very easy to get all of the information over here. And it's in one tool. I don't need to run between different tooling and different environments. And I have everything over here. Ingo, is it answer your questions? Are we good? Any other questions, maybe? You like the raccoon? All right. I think very good. Thank you very, very much, guys. I'm really happy to be here. It was a pleasure. So thanks again.
All right, that was outstanding. Thank you so much, Patel, for taking the time to share that with us, all of your expertise, and just being here. A quick reminder that today's session was recorded. Following this panel, you'll receive an email with a link to access the recording on demand. You can also find the recording on devops.com/webinars, where you'll find it in the on-demand section. As mentioned before, I do have $25 gift cards to hand out to Pedro A., Victoria S., Ingo S., and Ronnie S. Congratulations to the four of you. Please keep an eye on your inbox to claim the gift card. If you don't receive it there, make sure to check your spam folder. I also want to thank JFrog for sponsoring this. And again, thank you, Patel, for a great learning experience. And thank each of you for joining with us for the entirety of the presentation, all of your questions and your chat. It really helps us out. Lastly, if you don't mind taking our post-webinar survey to help us improve, continue giving great content. Before we close out, just again, thank you, and we look forward to seeing you on our next Techstrong Learning event. Have a great day, and we're almost to the weekend. Have a great weekend.
Thank you.